Okay, hi. Okay, good afternoon, grade 12. Okay, so this is just me explaining counting problems in probability. Okay, if you remember in the last lesson, we were talking about factorial notation when we deal with combination problems. Okay, now let's just look at the section here on how to deal with arrangements of objects in a row. Okay, so we've got a question here. This question is simply, in how many ways can three boys and two girls sit in a row? Okay, now how many ways can this happen? Okay, so we got a total of five children here, right? Okay, and the arrangement of these. Now, we're not told anything about who can sit next to who can sit where. Do we need to have three boys or what? So it's just three boys and two girls, which means it's five children that are just sitting in a row. So our calculation is just going to be 5 factorial, which is equal to, okay, so we're just going to find 5 factorial. All right, so 5 factorial, and the answer is, so that means there's 120 ways in which this is possible. Okay, we kind of learned that in the last video, right? All right, but now we got, okay, let's go to the next part there. All right, part B. In how many ways can they sit in a row if a boy and his girlfriend must sit together? All right, so what that means is we got a set of five children, boys and girls, right? But now there's this one boy who must sit with this one girlfriend. Okay, so these two have to be together, right? So we're gonna count them as one unit. What does that mean? It means we've got two other boys and we've got two other girls. Okay, no, we've got one other girl, we've got one other girl, right? Because the one girl is with a boyfriend. Okay, so there's two more boys left and three and one more girl left. Okay, so this is gonna count as one arrangement, and then two, and then three, and then four. So we just told that they must sit together. So they can sit in the middle, they can sit there, they can sit over there. Okay, so how many ways is that possible? So that counts as one, that counts as two, that counts as three, that counts as four. So that means this is gonna be in 4 factorial ways. Okay, so let's just quickly calculate what 4 factorial is. Okay, 4 factorial. Okay, so that's 24 ways in which this is possible. Okay, right, so just take note. These have to sit together. Oh, right. We also forgot the other thing. The boy is just sitting with his girlfriend. We're not told about how they're going to sit, so maybe it's the boy first, then the girl, or it can be the girl, then the boy. So this inside is also another possible arrangement, right? So that means there's 2 factorial, which is equal to 2 ways for the boy to sit with the girl. Now, we're going to multiply this. Why? Because obviously the way these two are going to sit and the way the rest of the row is going to sit is independent of each other. Remember, independent events. So that means we can multiply that. Okay, so now the total number of ways, okay, remember this 2 factorial is for the boy and the girlfriend. Okay, so the total number of ways in which this is possible is going to be what we got on 4 factorial multiply with what we got on 2 factorial. Okay, which in this case we know that was 24 and we know that was 2, so that means this is possible in 48 ways. Okay, right. This is very important because we're going to be calculating probabilities of that. Okay, now what else do we have to find out? Well, we have to find out in how many ways can they sit in a row if boys and girls are going to sit next to each other. Okay, so let's kind of just quickly draw a sketch of how this is going to look like. Okay, So we're gonna make a sketch now of what this is supposed to look like. Alright, so how many ways can they sit in a row if the boys and girls are gonna sit together? Okay, so what that means is that we must have a boy sitting with a girl, and then another boy sitting with a girl, and then another boy. Okay, so it must alternate like this. Alright, now how are we going to deal with this? Okay, so these two can sit in any order, those two can sit in any order, right? So that means this is a 2 factorial, and that's another 2 factorial, right? So, and then we can have now another arrangement where these count as 1 item, these count as 2 item, and then that one, so that's another 3 factorial. Okay, so now let's calculate that. All right, so you've got 2 factorial times 3 factorial times, sorry, my bad, it's 2 factorial times 3 factorial. Okay, so that means this is possible in 24 ways. 24 ways, right? Okay, what next do we have to find out there? Right, okay, it's fine, I can just take it one time. In how many ways can they sit in a row if just the girls are to sit together? Okay, nothing said about the boys, so this is what's gonna happen in this case. All right, so let me write D on there. Okay, and let me just push it up a little bit. Right, so now how many ways can they sit in a row if just the girls are to sit together? That's part D. Okay, so what that means is that these girls have to be in the same place. Okay, and then you've got these boys there. So what can happen is that you can also have another arrangement where there's first a boy and then these girls and then the 2 boys, and it can be in any kind of way. So we're gonna count this as 1 item because the girls have to be together. We're gonna count that as 1 item. So that means we got 1, 2, 3, 4 factorial for that. Okay, but now these girls are 2 different girls, so they can sit in any order, right? So that's gonna be by 2 factorial. Okay, so now we don't need to calculate the factorials one by one. We can just always do this 4 factorial times 2 factorial, giving us 48. So this is possible in 48 different ways. Okay, and then in how many ways can they sit in a row if just the boys are to sit together? Okay, so if just the boys are to sit together, then let's see. Right, so that means we should have 3 boys together. Okay, so this is gonna count as one thing. And then you got the girls and the girls. Remember, they can sit in any way. So that's 1, 2, 3 factorial. So that's 3 factorial. Meaning that's how they can be arranged by, okay, we got 3 boys. So these 3 boys inside can sit in any order. So that's another 3 factorial. Okay, and if we calculate that, this is what we get. So okay, let me just put it there. Right, 3 factorial. Oh, sorry, you must be able to see it here. I don't know how it's gonna work with the light, but let's try. Okay, that gives me 36 ways. Okay, so that is how we're going to be dealing with arrangements in a row. Okay, these exercises at the end of this lesson, please do them and just practice on how this works, and good luck with it.